2, 1, left.
I want to welcome you, class, in today's lesson where I'm going to discuss about the extraction of iron. Iron is extracted from its natural ore called Haemetite. We remember very well that an ore is a rock that contains a sample of a given metal that's worthwhile to be used to extract that particular metal. So the ore from which iron is extracted is called Haemetite. And to extract iron, first of all, you need to first know that the method of extraction is business. We need to look at the economic part of it. So the source of energy should not be expensive. Secondly, the source of the reducing agent should also be readily available. But iron is easy to extract because we are going to extract it using a reducing agent called carbon, because it is below carbon in the reactivity series, so carbon can be used to displace the oxide that iron is carrying. So the common ores of iron, we have Haemetite. Everyone say Haemetite.
Haemetite.
Haemetite is iron 3 oxide. Haem is in Latin, and in Greek it means iron, something that contains iron. That's why hemoglobin, there is that iron, okay? Because that component of the red blood cells is carrying iron. So iron means iron. This is our magnetite is called tri-iron tetraoxide. Everyone say tri-iron tetraoxide. Yes, tri-iron tetraoxide. The extraction of iron from this commonest ore, Haemetite. Look, man, make sure you're not talking. Okay? So Haemetite in the blast furnace. We need raw materials if we are to extract iron. One of them is iron ore, which is Haemetite. We need coke. Coke is just carbon. In some countries, more so those temperate countries, coke can be used as a source of heat during conditions of coldness in the winter. They can burn coke to release the heat that can warm them in their houses. So coke is just a form of carbon. Here, basically, you use charcoal. Look at charcoal and look at coke. They somehow have a similarity because it's all carbon. Then we have limestone. Limestone is just calcium carbonate. So here is a diagram to demonstrate the blast furnace. In the blast furnace, first of all, we have the inlet in which we put the raw materials. The iron ore is entered through the top, coke and limestone. So what happens is that Haemetite, coke, limestone, they are added from the top of the blast furnace. Because in this furnace there is a lot of heat. The word furnace means too much heat. Too much heat. So that's why we call it a blast furnace. It produces a lot of heat. Along this region, we have temperatures of approximately 800 degrees Celsius. The blast furnace has temperatures of about 1,800 degrees Celsius from the bottom. This temperature is just strong enough to burn carbon or coke. So carbon burns or coke burns in the presence of air. This furnace is well aerated, that air is entering. You can see with your eyes along these regions we allow hot air. So the hot air is just enough to enable the burning of carbon and oxygen to produce carbon dioxide. Moreover, this reaction is also exothermic. Can someone define for us what the word exothermic means? Lukman Mukhtar.
Exothermic is a reaction that loses heat. So it's
external. Uses heat. Repeat it.
Loses heat.
Loses heat.
To external environment.
You are very fine, but I need something small. Just that.
Exothermic
Yes.
is when the reaction
Yes.
loses heat.
The reaction that gives off heat to the surrounding.
Yes.
We clap for these two men. We
Yes.
clap for them.
Appreciate.
Thank you. Thank you very much.
Yes.
And the word exo is in ancient Greek language to mean external. A reaction that gives off heat to the surroundings. Good man, you're not allowed to talk when I'm teaching. So a reaction that gives off heat to the surrounding. So they will ask you, which of the following is an exothermic reaction? When carbon burns with oxygen, carbon dioxide is formed. That reaction is extremely exothermic. Back in your homes, you even use it when you're cooking food. You're burning carbon, charcoal is carbon. When you burn it, the heat is generated just enough to cook your food. So this reaction is an
How is it an exothermic reaction if it's gaining heat?
Yeah, sometimes reactions need certain conditions to take place. For carbon to react with oxygen, we need to apply heat. But in return, the reaction also produces more heat. Like if I want to burn my charcoal in the stove, I put heat from the matchbox. That heat, when the reaction begins, it releases more what? More heat. Okay? So for carbon to react with oxygen, we need to heat. But as the reaction progresses, it generates more and more what? More heat. Okay? So carbon dioxide is formed, and this will react with more coke or carbon to form carbon monoxide. So this carbon monoxide formed is our reducing agent. Okay? So carbon reduces carbon, carbon reacts with carbon dioxide to form carbon monoxide. So carbon monoxide is the reducing agent for Haemetite, which is our ore, iron 3 oxide. So iron 3 oxide reacts with carbon monoxide. Let us not forget that carbon is above iron in the reactivity series. So carbon will take away the oxygen. Carbon takes away, to reduce is to take away oxygen. So carbon takes away oxygen from the iron 3 oxide. That's why iron now is standing alone as a single element. In the beginning, it's even in liquid form. Although in the equation I'm using a solid state, but here the reactions are extreme. Iron is collected as a liquid. It's denser than slag. So iron is collected at the bottom here. So we form iron and carbon dioxide. Now, where does limestone come in? Limestone is calcium carbonate. Because the temperatures are extremely high, calcium carbonate decomposes to form lime. Limestone decomposes to form lime. Lime is calcium oxide. The calcium oxide which we have formed has a very significant importance. The calcium oxide that has been formed is going to react with an impurity. Where we extract iron from underground, there is a problem. The iron is not alone. It has combined with many other impurities that may not be useful in this reaction. So the presence of calcium oxide means that it will capture that impurity. I don't know if I can show you how silica looks, but just look at sand. Here we have a lot of sand, okay? Assuming we have a mineral there, maybe we want to produce zinc, to extract zinc, and we find out that the zinc metal is mixed with sand. So we need the zinc which is pure because we're going to use it for commercial purposes. So the only way to remove this impurity is by using another substance called lime. So calcium oxide combines with the impurity called silica to form calcium silicate. Calcium silicate is commonly called slag. So everyone said slag. Slag.
Slag.
Slag is calcium silicate. We have to know that this one is a neutralization reaction. A neutralization reaction. Okay, we have said the breakdown of limestone is a decomposition reaction. I want you to add these words on your equations. This one is a decomposition reaction. Write it there. Decomposition. A decomposition reaction is a reaction in which heat is used to break down a compound. So the breakdown of calcium carbonate to form calcium oxide and carbon dioxide is called a decomposition reaction. Okay? Now, the calcium oxide form is called lime. It combines with the impurity. We don't want the iron that is impure. We are going to use it for commercial purposes. So the calcium oxide will capture that impurity, silica, to form calcium silicate. This reaction is, this reaction is a neutralization reaction. Why? Because calcium oxide is a base and silicon dioxide is an acidic oxide. So a base and an acidic oxide, when they react, will form calcium silicate, and that reaction is a neutralization reaction. Whenever I react a base with an acidic compound, the reaction form is a neutralization reaction. Now we have removed the impurity. Slag floats on top, as you can see here in the diagram. Slag is less dense than iron, so it's going to float at the top. There is a tap that we can use to tap it out, such that it doesn't mix with our iron. So iron is more dense than slag. That's why iron can collect. We tap it out, we remove it, and then we can mold it into the different shapes, which we can use for making the. If you can.
Yeah.
Finally, we are able to get our iron. It may not be 100% pure, but at least it's 90 to 95% pure iron. We can remove it, process it in 2 bars. We can shape it in any shape that we want. The iron that we have formed is now pure or slightly pure to a certain percentage. With that, I want to thank you. Summarize this by saying that in this reaction, we are reacting iron 3 oxide, which is Haemetite, with carbon, and that reaction is going to produce iron at the end here. So I want to stop there, and I want to thank you for listening. Thank you.